Assalamu alaikum. In this video I'll be showing you how to measure lengths and distances accurately. Now the SI unit for measuring lengths is the meter. So all our discussions are going to be centered about this unit of measure called the meter, right? Whether we've got multiples of those such as thousands of meters called kilometers, or small parts or fractions of those such as hundredths of a meter called centimeters, or smaller than that you've got thousandths of a meter called millimeters, or even millionths of a meter called micrometers. Now in my hands I've got something known as a meter rule. It's a rod that is precisely 1 meter long. So on it you can see 100 tiny little centimeter divisions, and smaller than that you've got tinier millimeter divisions. So each millimeter is 1,000th of a meter. So you've got 1,000 of these tiny little divisions in this along this meter rod, and you've got 100 of these centimeter markings on the meter rod. Now if you're going to measure lengths of up to a meter, you can use a meter rule. But if you have to measure lengths that are greater than a meter long, you need to use something known as a measuring tape. You've got different types of measuring tapes. You've got different varieties of those. My particular measuring tape is 15 meters long, although you have different variations for those as well. So rather than taking your meter rule and flipping it every time you complete a meter, which would result in inaccuracies, because then you'd have to account for the thickness of the meter rule as well, and besides the meter rule could slip or move. Rather than introducing all of those different errors, we tend to prefer using this measuring tape, where the measuring tape is a single tape that extends up to its maximum range. Apart from the measuring tape, you could go for a trundle wheel, which has no limits on it. So it's a wheel that's attached to a rod, and you walk along with the wheel where the wheel has a fixed circumference, right? So for example, a trundle wheel could have a circumference of 0.5 meter. So every time you get a complete rotation that results in a click, it means you've traveled 0.5 meter. So these are different ways of measuring large distances or large lengths. What if you've got tinier lengths than that? So if you've got lengths that are smaller than a millimeter, for example, then you might have to work with one of these. This is called a vernier caliper. So it's an instrument, it's a device that can measure lengths up to 1/10 of a millimeter. So it's far more precise. It's a far finer scale compared to your regular meter rule, which is only precise up to a millimeter, right? So in this case, you've got a precision of up to 1/10 of a millimeter, sometimes even smaller than that, but you're limited in the range, right? So the maximum measure this can take is from 0 up to 15 centimeters. Now, if you want to measure something finer than that, so if you want a further precision, a precision of up to 1/100th of a millimeter, so now you're talking in terms of micrometers, so you might have to go with one of these. This is known as a micrometer screw gauge, and it can measure up to 1/100th of a millimeter. And of course you've got different types of micrometers as well. This particular micrometer can measure up to 1/100th of a millimeter, and it's got a maximum range of 2.5 centimeters. So this device cannot measure lengths and distances greater than 2.5 centimeters. Now, whenever you measure a length or a distance, and you try and read a reading from one of the many markings on the scale, what you have to ensure is that your eye is placed at 90 degrees to the marking. So in other words, for example, if I were to measure the length of this vernier caliper, for example. So let's put this away. So if I were to measure the length of this vernier caliper, it would be wrong to try and look at the markings at an angle. So say, for example, reading it as 23 centimeters, but reading it at an angle, right? Because that then leads to something known as a parallax error, right? So the correct way of reading these would be to view them from 90 degrees from directly above in my case, and that would give you the correct reading. As an example of parallax error, I've got a wall clock in front of me. Evidently, you can see that the seconds hand is stopped at 5, right? So it's 25 seconds. If I hold the clock at an angle, the needle appears to be somewhere behind the 5 marking. So it appears to be at the 24th second instead. This is an example of parallax error. So because you're viewing the markings at an angle, you read the values differently. So the correct way of reading those values in order to avoid these mistakes would be to view them directly from ahead or from above at 90 degrees. So coming back to our example, first of all your readings need to be taken at 90 degrees. The second thing to ensure is that sometimes the instruments get damaged, right? So your reading, in other words, don't start at 0. So for example, if my meter rule is chipped at the end, then naturally the readings won't start at the 0 mark. And all my readings would include something known as a 0 error. So a 0 error occurs when your starting point doesn't start at 0, 0, right? So it starts at some other value. So a good idea to avoid the 0 error would be to start at one of the later markings and simply removing that additional amount. So for example, I might start at the 5 centimeter mark and simply subtract 5 centimeters from my final reading. So that would give me a far more accurate value because then it accounts for the 0 error as well.